Now there's two more things I want to emphasize. One is the importance of silver nitrate, and two is something called a ring expansion. So let's start off with silver nitrate. Now silver nitrate, the importance of it is that it forces an Sn1 mechanism. And the way it does that is that when silver bonds with bromine, it forces it to precipitate into a white solid. And so bromine actually leaves the substrate. And so in this situation, for example, the carbon, the primary carbon right here that was connected to bromine, is now a primary carbocation. It lost a bond. And we just have silver bromide on the side along with nitrate floating around in the water. Now, a primary carbocation is actually quite unstable. And so a methyl shift will happen. Now, this methyl shift is special, where it's actually going to expand the ring, because our neighbor here, this carbon right here, has two carbon bonds. It can actually donate one of its carbon bonds to the carbocation. So let's start labeling this. I'm going to call this carbon A, I'm going to call this carbon B, and call this carbon C. The bond between carbon A and B right here is going to break, is going to stay attached to B, and now attached to carbon C. And so we get this next intermediate, which is going to be now a 5-membered ring. And so let's draw this. Let's label our carbons again. I'm going to call this carbon A, carbon B, and carbon C. And here is our new bond that we had with carbon B and C. Our old bond between carbon A and B is now gone, and we still have that other carbon bond carbon A normally has. And now our original primary carbocation is now no longer a carbocation, it's just a secondary carbon. And our carbocation is now on carbon A. Why? Because A is the one that lost that carbon bond. So now we have our carbocation. Now, a secondary carbocation is better than a primary. And so this ring expansion helped not only reduce the angle strain, the ring strain that we have in our cyclobutane, but also made our primary carbocation a secondary one. And now water, which is floating around, is going to act like a weak nucleophile. And with its lone pair, it's going to attack that carbocation. And at the same time, it's going to lose one of its hydrogens because it's going to become positively charged when it has 3 bonds. And so our final product looks like this. It's a 5-membered ring, and it has an alcohol group right here. Now, originally it was a water group that we positively charged, but it would lose one of its hydrogens because of that positive charge to maintain a regular neutral charge. And so this is our final product. So we just showed a ring expansion and why silver nitrate is useful. It can force an Sn1 mechanism when it's only a primary carbon.